Hello, everyone. Pleasure to be here to discuss engineering for applied machine learning. Before you all start to look for the presentation screen, I actually don't have slides. We just have a chat. And I also start by saying it's my first time joining this conference. It's super cool to hear all the great work that were done by other presenters. It's humbling to hear those ideas, a lot to discuss. So my name is Yuchen. I work for Instacart and support our fulfillment marketplace organization. My teams are responsible for developing technologies to empower a balanced, sustainable, and resilient marketplace. And what that means is we want to efficiently meet consumer demand and make sure that your grocery gets delivered quickly and efficiently. We want to empower our shoppers and make sure they get meaningful work and earnings opportunities on the Instacart platform. So machine learning, along with technology innovations across system engineering and operations research, are the mainstay of the work we do. We use machine learning to drive a wide range of marketplace opportunities. For example, predictive modeling is used extensively in our systems. It is super important that we know, for example, how long it's going to take to fulfill an order by modeling how fast can someone drive to the store, pick up all the items in the order from the store and get those delivered. That way, we can promise the fastest and reliable ETAs to our consumers when they check out, and also dispatch orders to our shoppers at the right moment to make sure that they will arrive on time. Forecasting is another critical component of our system to ensure our users can order whenever they want to at the speed they desire. It is important to estimate how many orders we will receive at what time and also at which store, so we can plan ahead with shoppers on the platform. So Instacart is a continuation of my long-time passion for applied machine learning, which actually started in a very, very different domain. It was in 2009 when I was a PhD student collaborating with Google Research in the area of speech recognition. So unlike, I think I'm, as I mentioned, I didn't have slides, so it would just be chatting, with my screen. So unlike today's speech recognition products in 2009 were a little frustrating to use because the recognition accuracy was far from perfect at the time. So there were lots of efforts put into improving speech recognition at the time. One of those efforts was to evaluate the use of deep neural networks. I did not participate in that effort directly, but was very fortunate to witness the tremendous excitement when deep neural networks saw a huge improvement in accuracy compared to state of the art at the time. It was acclaimed by the team as 10 years of speech recognition R&D launched at once. It was fascinating to see how machine learning algorithms, data, and engineering really came together at that time to advance boundaries of technology and enable transformative product improvements. Clearly, this improvement in speech recognition would not have been possible without the core innovations in deep learning algorithms. The amount of speech data was also critical. As we all know, machine learning isn't very helpful without data. But the part I was fascinated most about was the innovations in engineering system that made it possible to train such large-scale neural networks. And in fact, an entire array of engineering tools and systems have been invented since then to make ML development across many applications like those we heard today. So personally, I have worked on ads, search, recommendation, and now marketplace at Instacart. And in every single one of these applications, I've seen the success formula of algorithm, data, and engineering to drive business impact. The algorithm and data often vary across these applications, but I've found that the engineering challenges are often very, very similar across these domains. So today I'd love to just share one aspect of engineering problems for applied machine learning, which I call idea to result. So what is idea to result? It is the time it takes between you wake up in the morning with an idea to improve your machine learning model to the time when you know that the idea is good. So clearly, we want idea to result to be as fast as possible. So what gets in the way of us getting results quickly? For example, say you work on a recommendation and wake up with an idea of a new user feature that you think will improve your recommendation results. However, that feature may not be available in your feature store, and perhaps it's not even logged in the production system. You end up spending time writing feature extraction pipelines, or even worse, sometimes having to wait for the production logs to gradually accumulate through logging, which would take months, before you can even start to train your model and test the ideas in experiments. Or imagine you read a paper about a cool new ML technique that claims to be effective in your type of ML application. However, the ability to train and evaluate this kind of ML model may not be supported by the current ML workflow you have. So you may have to file a request to have that implemented, and the ML infrastructure team may have to prioritize that in some way, which causes further delay. Sometimes the bottleneck is neither in feature engineering nor ML workflow, but the fact that you need to run live experiments to gauge success of your idea, which requires you to go through a full productionization cycle of a test model and wait for experiments to come in, and this would take at least a couple of weeks before you can get the results. So this list can go on and on because every application and system are different. But in my experience, they all tend to be things we can improve through analyzing the engineering systems that work between your idea and getting your results and make them work faster. So why does idea to results matter? Well, all engineering problems become easier to solve if we can move faster. For most applied machine learning problems, we take an iterative approach by constantly testing new ideas. So the speed at which we can iterate on our ideas, really governs how fast we can learn and how much impact the team can generate. Faster idea to result also means we can catch bugs earlier. Have you had experience working through weeks to train an ML model, and then more weeks to get the experiment data, only to realize that there's a bug in your feature extraction code that made all the results invalid? While we don't have many MLOps tools to catch these issues automatically and minimize them, it is still much better if we can catch them sooner. Also, depending on your ML applications and your business environment, sometimes there are cases where you have to make model changes very quickly. For example, there may be a need to assess a new data provider where you need to make a business decision in a couple of days or weeks, and being able to get from idea to result within reasonable time frame really becomes critical in those scenarios. If you lead a applied machine learning team like I do, idea to result is also an important gauge of productivity of the team, and productive teams are happy teams. And it is fun for machine learning engineers and data scientists because we get to test ideas faster and then get the feedback loop quicker. It is also fun for backend and data engineers on the team because through the lens of idea to results, their work is surely the enabler and force multiplier to all the impact that the team is having through these ML ideas. So we talked about what is idea to result and why that matters. How do we make it useful? Well, the first step is to start measuring it because we can only improve what we measure. Every ML system probably has a different bottleneck. So go identify those. And very likely you would be pleasantly surprised by how much faster you can iterate through ideas by investing in just a few new tools and infrastructures. If you're a machine learning engineer or data scientist and find yourself waiting weeks or even months to test an idea, don't assume it has to be like that. Surface what takes time between your idea and the results. Discuss among your fellow engineers to come up with solutions. And for example, oftentimes a live experiment takes too long to run. And this may be the time to think about developing offline simulations or offline metrics to estimate production impact of your model without having to run a live experiment for every new idea you have. If you are a backend or data engineer, your work is probably already making idea to results faster. This is truly impactful and high leverage work, and I'm sure there are a lot of opportunities that you can drive even further impact, through these lenses. With that, I think I'm getting pretty close to my 10-minute mark, and thank you all very much for attending this. I hope this is useful, and you can tell I'm very passionate about this area on the intersection of engineering and machine learning. And please don't hesitate to reach out, and look forward to chatting more with you.